All right, welcome back. Today we are going to talk about a more advanced topic, which is backtracking. So backtracking is a technique for solving problems recursively by building the solution incrementally, one piece at a time, given the constraints of the problem. This is why we learned about recursion early, is because we want to learn about backtracking. And the reason why we want to learn about backtracking is because our end goal is to build a Sudoku solver. Now, what does it mean by building the solution incrementally, one piece at a time, given the constraints of the problem? Well, let's look at an example. So what do we see here? So obviously this is a maze, and backtracking is actually quite useful for mazes because there are a lot of constraints. And what are the constraints here? The constraints are the walls. We know that we cannot go through walls. So the goal here is to get to the end without going through a wall. So that's basically what a maze is. So a lot of the problems that we will solve using backtracking will have a series of decisions, like left, going right, or going down, going up. And whenever you have to make a series of decisions, you might make a wrong decision. Like for example, in a maze, you might have gone right instead of going down, but sometimes you wouldn't know it's a wrong decision until later on when you reach a dead end. So what do you have to do? Well, what you have to do is you have to backtrack to the point where you made the wrong decision. So you were here, and then you're going to backtrack all the way back here. All right. So then in some sense, you're going to backtrack all the way to your starting spot. And then this time, instead of going right, you go down. And then you go right, you continue your maze. Oh, you reach another dead end. So there you go. You have to backtrack again. And how do you backtrack? You go back to your original point where the decision was made wrongly, which is here. And then you continue going to the opposite direction that you came from. And then same thing, you backtrack, you try to go up, you go down, you go right. Oh, you reach a dead end, and then you backtrack. And then you go here, up, left, up. And then eventually you're gonna reach your destination. And then that's the solution that you're trying to get. You're trying to get the path where it leads to the end. But how you get to that path is that you have to make many mistakes, and then every time you make a mistake, you backtrack, you go back, and then you continue by going the other direction that you wanted to try. So here are other examples of problems you can use backtracking for. We've already mentioned this, Sudoku problem. Because we're going to make a Sudoku solver, obviously Sudoku is a backtracking problem. So how is it backtracking? You know, it's not as obvious as a maze. Well, the same goes here. For example, instead of going right, left, down, or up, you instead will choose a number. For example, let's choose the number 1 here. And then, okay, that seems to work. Let's put the number 2 here. That seems to work. Let's put the number 4 here. So obviously, this is not the right way of doing Sudoku, but right now I'm doing a brute force. And then we want to put 6, but then that doesn't work anymore because there's a 6 over here. So what do? You backtrack. Okay, you go back here. And then you say, okay, what if instead of 4, I put 6? Okay, and then now I want to put 8, and then I want to put 9, and then I want to put 4, right? And then you continue until you realize there's nothing you can do because there's just a mistake, and then you backtrack. Like for example, if I continue here, then let's say I want to put 2 here, 1, 2, 3, 4. We could put 4 here, 1, 2, 3, 4, 5, 6. Oh, 6 is here, and then 7, I could put it here, and then 8. Oh, see, here's the issue. I can't put 8 here because there's already an 8 here. So then I have to backtrack, and then maybe put 8 here. Well, I can't do that either. Then I backtrack. I go all the way back, right? So maybe I shouldn't put 8 here. Maybe I should put something else, and then maybe I should put 4 instead, and then we continue. But that wouldn't work either. Then we backtrack all the way back. So then maybe we should put 8 here, and then 1 here, etc., etc. So that is why it's a backtracking problem, right? Because the way you think about it, you might think about it intuitively, but when you're coding, it's a little bit more tricky, right? So anyways, let's look at another example of a backtracking problem. Another example would be the 4 queens problem, or generalized, the n queens problem, where the number 4 means that we are in a 4x4 board, and we are trying to fit 4 queens onto this board. If you don't know chess, a queen, they can take all pieces that are horizontal of her, so on the same row, or on the same column, or on the diagonals. So for example, if you have a piece here, then that piece is safe. The queen cannot take it. However, if you have a piece here, then a queen can take it because it is in the same row. All right, so that's what a queen is. So the key here is to put 4 queens such that the queens cannot take themselves. For example, if I had a queen here and had a queen here, that would be a no-go, right? Because the queen can take each other. We are trying to place 4 queens such that the queens cannot take each other. All right, so how is that related to backtracking? Well, how would you solve this problem? So the first thing we can do is maybe we just add a queen. And the first queen we add is really easy because there are no queens on the board. So you could basically put the queen anywhere. So let's just do this column by column. All right. So we know that once we place this queen on this column, you cannot put any queen on the same column again. So let's go to the next one. All right. I can't put it here because the queen is beside me. I can't put it here because of the diagonal. So let's just put the queen here. All right. So I'm still going forward as the algorithm goes. And then the next queen, okay, I can't put it here, I can't put it here, I can't put it here, nor can I put it here. Why? Because this queen can take these 3. And then if I put it here, this queen can take this one. Well, that's a problem because we have to have at least 1 queen each column because we have to put 4 of them, right? So already now there's a mistake. So this one was probably a mistake. So what would we do? We would backtrack. We would go back to our first queen inputted, and then now we'll put the queen somewhere else. All right. And then next, where do we put our queen? We could put our queen here. And then next, where can we put our queen? We can't put it here. We can't put it here. We can't put it here because of this queen. Nor can we put it here because of this queen. Oh my God. That means I have to backtrack again. All right. Well, I've tried everything so far. I tried this one and this one. Okay. So maybe this one was wrong. All right, I'll backtrack all the way to the beginning. Now I have no queens. All right, let's start the queen here this time. And then the next one, there's only one spot I can put it. I'll put it here. And then the next one, we can put it here. And then the final one, we can't put it here, we can't put it here, and we can't put it here. Then the final one, we can put it here. And there you go. And we actually solved this problem using our mental backtracking. Of course, the computer will do it way faster than us, but basically that's what the computer would do. So the blue queen takes all of that. This is the green one. Goes here, right? It never takes any other queen. I'll do yellow. This one goes here. All right, good. Doesn't take any queen. And then the last one, and then the diagonals. Yep. So there you go. We solved 4 queens using backtracking with a human brain. All right, one last final example. This one is actually an even simpler example. It's kind of like the maze problem. But for this problem, what I want you to do is to get the robot to go home without crashing into the X's. And the robot can only go right or down. So we want to find a path. Now, obviously the path is right here. But if the maze is really big, it's actually quite difficult for a human to find a path. But computers can solve it really well because they'll just do a backtracking algorithm. And what the backtracking algorithm would do would be they would try every single move. Let's say they always go right until they can't. So the robot will go right and then they'll go right again. But that doesn't work because they landed on an X. So they'll backtrack to the previous decision. And then they'll go down instead this time. And then they'll go right. Oh, it doesn't work. So they'll backtrack. All right, they'll go down and then they'll go down instead. And then they'll go right. This time it works. They'll go right again. And then they'll go right again, but they can't because they went off grid. And then instead they'll go down. This one is an easy example, but imagine if you had something a little bit more complicated like this, then, well, it's not that complicated for us humans. It's very obvious. You just go right there. But for example, the backtracking algorithm, what they would do is they would go right, and then everything is good. They'll go right again. Everything is good. They'll go right, and then they won't go right anymore because it's out of bounds. And then they'll go down, and then what they realize is that they're stuck. So then what would they do? They would actually backtrack all the way back to the beginning. And then instead of going right this time, they'll go down. And then they'll try everything. And then in the end, they'll succeed. So that's how the backtracking algorithm works. Now, backtracking sounds simple because, like I said, us humans, we do it intuitively and naturally. But how do you implement it in code? That gets a bit tricky. But to understand how to code it, we should understand exactly what's going on in our head when we do the backtracking algorithms without even know it. And I basically showed you how your brain works in this robot go home example, but slowing it down 100 times. Because with our brain, the moment we saw the robot and the end and the obstacles, we knew exactly how to get there. But imagine if you had a huge map, right, with a bunch of X's. In some sense, if you think about this maze, multiply this by 100 times. What are you gonna do? You're not gonna be able to solve it in one shot. You're gonna do a little bit of brute force. You're gonna try one spot, and if it doesn't work, you're gonna go back and try another path. So this is not easy. Because it's not easy, it requires a computer to do it. And a computer will use the backtracking algorithm, which is what you do subconsciously, but now you code it specifically for the computer or the program to do it programmatically. All right, so that's pretty much for backtracking in terms of the concepts. In the future lessons, we will actually implement it in code and we'll understand how to use the backtracking algorithm and then to finally solve a Sudoku puzzle. All right, I'm quite excited. And if you don't quite understand everything about backtracking right now, don't worry about it. I mean, this is only the first lesson. I do suggest you to look around the internet and maybe you can read some of it, but don't worry about it because I'm going to have a lot of examples and it's going to be much easier once I put things into code. All right, thank you so much for watching. I'll see you in the next one.